Hello, my name is Emilio Camahort, and I'm going to be introducing you to animation in OpenGL. First, I'm going to talk a little bit about computer animation generally. Then, I'm going to tell you what kind of support does GLOT have for animation. Then, I'm going to tell you how to design an application that uses OpenGL and GLOT for animation. Finally, I'm going to give you a couple of examples on how to program frame-based animation and how to program time-based animation in OpenGL using GLOT. Remember that OpenGL is a library that renders 3D graphics, and that GLOT is a support library that provides event handling for OpenGL. GLOT events can also be used to program computer animations. And these events are the ones that we're going to be using in today's lecture. Before we continue, let me remind you that we are assuming that you know how to create a C++ console application using Visual Studio 2005, how to install GLOT, the library needed to program with OpenGL, and how to compile and run a C++ project using Visual Studio 2005, OpenGL, and GLOT. Okay. Let's start with our presentation. Computer animation is made doing the following. First, you have to create a sequence of static images called frames. These frames include moving objects that change of position and orientation from one frame to the other. This is the same technique that is commonly used in movies, video, and TV. In computer graphics, animation programs have to follow these steps. For each frame, we're going to follow 3 steps. The first one will check if a stop condition has been reached, that is, if the program has to be terminated. The second step that has to be run is we have to update the positions of all the moving objects. And the third step that we need to run is we have to redraw or redisplay the scene. There are basically 2 animation techniques that we are going to study using OpenGL and GLOT. The first animation technique is called frame-based animation, and the second animation technique is called time-based animation. In order to implement these 2 types of animation, GLOT has the following support for animation. There are basically 3 functions that support computer animation in GLOT. The first function is called GLOT swap buffers, and this function allows you to swap the front and the back buffers when using double buffering in GLOT. Double buffering is a technique that has 2 color buffers and prevents flicker. At any time, we are drawing in one buffer and we are displaying the other buffer. When we want to exchange them, we call the GLOT swap buffers function. The second function that supports animation in GLOT is GLOT idle func. This function installs a callback that is called every time there are no events pending for processing. In fact, this may be called repeatedly as long as there are no events pending processing. The third function is GLOT timer func that installs a callback that is invoked every time a given time has elapsed. We won't be using this function, but you may find it useful for your applications. There are 2 more functions that are used in GLOT to support animation. GLOTGET with the parameter GLOT elapse time returns the time in milliseconds that has elapsed since the program was started. This function allows you to control the time related to a given animation application. Finally, GLOT plus redisplay generates a display event that forces the scene to be redisplayed or redrawn. This function will invoke the display callback. So what do we have to do in order to design an animation application? Well, we're going to see how to do a simple application, example application, where an object will be moving along the positive axis, and we're going to have a global variable posX that will store the object or the position of this object on the x-axis. We assume that the positions of all the objects in the scene are stored in these global variables, and we assume that the display functional display is the same for the two techniques, animation techniques, that we're going to be addressing. This display function will have two parts, a part that will draw the scene and the second part that will invoke the GLOT swap buffers GLOT function. The remaining functions depend on the technique that we want to use. So let us start with frame-based animation technique. Here we install a callback function online that GLOT will run when no other events are waiting to be handled. The program updates the position variables before drawing a new frame inside of this function, and then it invokes the GLOT post-display function. So basically, we will have this idle function that updates the position. Position updates means that the position is going to increment it by a certain value, and then we invoke the GLOT post-display callback. The problem with this approach, with this animation technique, is that the faster the computer, the faster the animation runs. And we may want that the animation runs at the same speed on any computer. To do that, we implement time-driven animation. We start by assigning a speed to each object. For example, we assume that our object moves along the x-axis at 10 units per second. Then, when updating the position of the moving objects, we take into account their speed and the time that has elapsed since the last update. So here we are going to take into account elapsed time and speed of the objects. Here is how we implement it. Now, the update position function takes a parameter milliseconds and uses that parameter that gives us the number of milliseconds that have elapsed since the last update. We use this value to compute the increment of position of the object that moves along the x-axis. The on idle function is now a little bit more complicated because we have to read, we have to get the elapsed time, we have to compute the time that has elapsed since the last update, and if that time is higher than 0, we have to update the position and we have to redisplay the scene. In order for this program to be run, we need to store the time at initialization. To do so, we have to run the following code segment inside the initialization routine. What we do is we get the initial elapsed time and we need to initialize, or we need to configure the GLOT idle function callback. With this initialization and the previous code, we can do time-driven animation, and that way we can make sure that the objects move at the same speed regardless of the computer where we are running our animation code. And this is all I wanted to tell you about animation in OpenGL and GLOT. Thank you very much for your attention.